Welcome to GRE Snacks, snackable episodes about the GRE exam and graduate school admissions. I'm Tyler, founder of Achievable. We have an affordable online GRE course that gives you everything you need to ace your GRE. Full textbook, tons of GRE questions backed by our memory-enhancing algorithm, and full-length practice exams. You can try it out for free at achievable.me, and if you like it, the code podcast gets you 10% off at checkout. Also, if you have a question or topic you'd like us to discuss in a future episode, please contact me at tyler@achievable.me with the subject line podcast topic. So let's get started. We have Irfan Gula. I hope I pronounced that right.
Yep.
It's been a minute. I have Irfan on the show with us again today, and we're super happy to have him back. Do you mind introducing yourself really briefly for the people who haven't heard you before?
Sure. First off, thanks again for having me. So my name's Irfan Gayula. I am a professional GRE and GMAT tutor. I've been tutoring these exams full time since 2009. I've achieved a perfect score on the GRE, and I'm sole author of McGraw-Hill's Guide to the GRE, which is in its 10th edition and has sold over 100,000 copies worldwide.
Very cool. Wow. So that gives you a lot of information or knowledge to draw from on our topic today, which is what are the top GRE quant question types you need to practice?
Yeah,
So
for sure.
take it away.
Yeah, it's a really important question. I find a lot of times people, to some extent misallocate their study time, spend maybe a little bit too much time on topics that are less commonly addressed. So yeah, let's start with, what the core content you need to master, and then, we'll get to some of the lesser tested topics. So the most important topic is arithmetic. Now, I'll define arithmetic broadly as dealing with fractions, percents, ratios. So the importance of this topic, number one, you're going to get a decent chunk of just standard discrete quant questions and quant comparison questions concerned with it. But equally importantly, data interpretation, which is always going to be 3 questions per quant section, almost exclusively will deal with arithmetic, actually making sure you're able to quickly do calculations, manipulate numbers. So developing a solid foundation in that area is important. Now, getting into some, a little bit more granular with respect to arithmetic, percentages in particular are the most important topic of the exam. You need to understand percentages inside and out. So various manipulations of percentages, things like understanding if they tell you X is 5% of Y, how would you express that? Or if they tell you after, so percent increase and decrease in various formulations is very important. So if they tell you, after a 10% increase, the price of a shirt was $120. What was the original price? Being able to properly do that, making sure that you're referencing the proper base and setting that up. Equally important within that as well, percent greater, percent less. I find pretty much at every section, in my experience, you're going to get one question asking about percent greater, percent less than. And, again, the kind of thing, it might seem simple, but it's also very easy to make mistakes, in particular having the wrong denominator in your setup. So just mastering that, making sure if I ask you 60 is what percent greater than 50, that your denominator there is 50 and not 60.
Right.
Yeah. So high level with percentages and fractions, similarly, being able to manipulate fractions quickly, being able to simplify fractions. Also, fraction theory is pretty commonly tested. By fraction theory, what I mean is, understanding if you have a positive fraction, the bigger the denominator gets, the smaller the fraction becomes, and so on. Different versions of those principles. So
Right.
as a starting point, that is the most important topic, the one you need to master above all else. And another point I want to make there is, we talked about this in a previous podcast, but it's important to emphasize, don't be over reliant on your calculator. It's easy to think with arithmetic, oh, well, you know what, like if I'm adding some fraction, I'll just put my calculator, good to go. But it's going to create a lot of complications if you're too reliant on it. You'll introduce some inefficiencies. It'll be hard to track any errors that you may have made in putting the numbers into the calculator. So I would highly recommend developing as strong a muscle as possible to deal with fractions, simplify fractions, work with fractions on your paper. Do not use the calculator as a crutch.
I also think that like fractions on the calculator just are kind of rough sometimes, right? Like, what's 4/11ths? Well, on the calculator, that's a really nasty number that doesn't make any sense, right?
Exactly. So, yeah, right. Yeah. If it's numeric entry or even multiple choice, the choices are fractions. If you're going to take a fraction, turn it into a decimal, do all that math, turn it back into a fraction. I mean, yeah, maybe it'll work. Maybe you'll get an approximation, but you're gonna position yourself to just increase the likelihood of making a mistake, which, as we discussed before, silly mistakes will really hurt your score.
Right. Also, I think there's something to be said for the fact that the test writers clearly have a way for you to solve it in mind when
Uh-huh.
they write a problem,
Yep.
right? And so if you're solving a fraction problem by turning it into a decimal, doing all the math and turning it back, that's probably not what they had in mind.
Yeah,
And
for
then,
sure.
yeah.
Yeah.
So it's like, not to say you have to do things their way 100% of the time, but generally speaking, they have a path in mind, and it's usually easiest to go on that well-tread path.
Yeah, exactly. The path they have in mind is the most efficient path, and efficiency is half the battle on this exam. So yeah, putting yourself in a position to identify that pathway, not to develop bad habits that whereby you'll detour into, suboptimal approaches is really important.
Yeah, for sure. Yeah, so first one was just basic arithmetic, and I would put around that, or as an addition to that, also like dealing with the wording of these problems.
Oh yeah,
Like you
for
talked
sure.
about, like 50 is, or like, there's a big difference between 50 is what part of 60
Uh-huh.
versus 60 is how much greater percentage than 50,
Yep.
right?
Yep.
And just like, what are they really asking, and how do you arrange the math?
Yeah, definitely. And that's a part of, like, you can lull yourself into a sense of complacency thinking, well, you know what? Percentages are the easiest topic. I do these all the time at work or my day to day life, but they could work in such a way that if you're not really paying attention to detail, you'll make a small mistake, which will just sabotage the whole question. What's interesting to know is, especially with things like percent greater, percent less, they'll have traps for people who have the
Hmm.
wrong denominator, right? Like they know what they're
Yeah,
doing. They know the kind of mistake people are making. That's what you obviously watch out for.
yeah, for sure. So great. Yeah, what do you think is up next after that?
Yeah, so I'd say algebra. Now, I'm going to define algebra as just working with variables, manipulating equations, manipulating variables generally. Um, for two reasons. Now, algebra proper is pretty commonly tested. So we'll define that as linear equations. So, like something like 2x plus 3y equals 12, 3x plus 4y equals 18, develop doing a system, blah, blah, blah. Quadratic equation. So like, first off
Right.
within quadratic equations, understanding like if x squared equals 16, you'll have two solutions, but equally importantly, being able to deal with what we'll call the special products. You guys probably have a different term for them, but a plus b quantity squared, a minus b quantity squared, a plus b times a minus b. Memorize those forwards and backwards, be able to work with those as they present them in different contexts. The point being, a lot of times with quadratic equations, they will take these special products, disguise them. And the thing is, if you don't know the special products in their standard form, you're not going to be able to identify when they're disguised. Okay, so
Yeah. Yeah, and the disguising is often kind of the tricky part. Like that was something that I found.
oh yeah, for sure,
Like
yeah,
you got to you're like, "Wait, what? How the hell can I possibly do this?" And
right,
it's probably a quadratic in disguise that you need to remember those.
yeah, exactly. Like the example that comes to mind for me is if 1,001 squared minus 999 squared. I mean, like first off, your calculator is not going to have enough digits to do the math on that, so that's not available. It's like, well, what can you do? I mean, that's where you have to be able to see, okay, that actually is the difference of squares is a squared minus b squared, manipulate it accordingly. But the kind of thing again, if you don't know the difference of squares generic formula, it's going to be tough to identify it when it's disguised.
Yeah, or one that I saw when I took the GMAT was it was like a million squared minus x and then like a 999 squared plus x or something like that. Like it was like
Oh, yeah, that's interesting.
it was
Sure.
like one of the foil ones. Yeah,
Uh huh. Uh huh.
it was one of the special rules where obviously if you foiled it for real, it would be still a huge mess. But there's like a
Right.
special rule to minimize that
Yeah, I think
that
it
I did
sounds
not
like
know.
yeah, it sounds like maybe you have to turn the million into or turn that second number to a million minus one or something like that. I mean, depending on the question, but yeah.
Or
But
yeah,
again,
that's what it was. Yeah, yeah.
yeah. The point is like these questions, but that's what they do, right? Just high level, just across. I mean, what makes a question hard? They'll take a simple concept, put it in a form where it's not going to be as easy to identify, where you have to be a little bit flexible in your approach. But again, the flexibility does presuppose a very solid foundation in the core content.
Right,
Um,
exactly. You have to have that foundation in order to even try with some of these.
yeah, exactly. Yeah. And then expanding on algebra, another really important topic that I find is a trouble spot for a lot of people's exponents, powers and roots,
Hmm.
radicals, all that fun stuff. Basically, Like first off, yeah, you need to know the power and root rules inside out. There's just no way around that. Now, if you listen to the previous podcast, I'm not a big fan of brute mindless memorization, right? Understand the rules. That really is important, but you definitely need to know them, be able to, get flexibly implement them. And the reason I say I find that this is a trouble spot for a lot of people, just like exponents, A, there are a lot of rules that you need to know. B, it's not something we do on a day-to-day basis, and it's easy to look these questions, just dive into doing too much math and making the questions a lot more challenging.
Right, like when do you add the exponents? When do you multiply the exponents? Like how do exponents and fractions interact?
Right,
It's
right,
all that
exactly.
good stuff. Yeah.
Yeah, like negative exponents, how to deal with those, etc. For sure. Yeah. Um, and in particular, I mean, the one piece of advice I'll give anybody listening to this who's having trouble with exponents, and again, this is a little bit general, but it generally will be helpful. Express the bases in prime form. If all else fails, that probably is going to make your life easier. Because usually, if it's in prime form, then you'll be able to use some rules and then go from there.
Got it. So if you're looking at like 32 or
Uh,
something, like you should just make that like 2 to the fifth. Just
yeah,
get that out of the way.
again, for the like, obviously it depends on the situation, but if you're not sure where to go, that usually is a good default. Like especially, it was like 32 to the fifth over 16 to the fourth. Well, all right, you could make them both base two, then start applying rules. Whereas on the surface, rules would not be available.
Right. Exactly.
Um, and yeah, and then other components of algebra are really important. Inequalities, absolute value,
Hmm.
definitely tougher topics, but heavily tested as well as a subset of algebra. In particular, with inequalities and absolute value, being able to manipulate inequalities properly. Understanding for the most part, you manipulate inequalities the same way you manipulate equations, with the exception when you multiply divide by negative, you flip the arrow, and if you don't know the sign, then you simply cannot multiply or divide. And I find that's a trouble spot for a lot of people. And equally importantly, absolute value. With absolute value, the one thing I will say, again, it's one concept I find people have a sense of complacency where they're like, you know what? When I see absolute value, I know it's simply positive, negative, etc. Like there's two solutions, but
Hmm.
there is more to it. Ultimately, you should always think about absolute value in terms of distance from zero. That's conceptually what's going on, and that sort of baseline frame of reference will help you conceptualize the situations a little bit better.
Right.
Yeah, and so yeah, that's algebra. Now the other reason algebra is so important, and algebra proper is tested pretty heavily, but also being able to manipulate equations is going to be important for word problems in geometry as well, where you're going to have to introduce a lot of variables, which does lead into the next major topic, which is geometry. And one
Hmm.
thing, just like a little bit of background on the GRE, which is interesting. Geometry wasn't as heavily tested back in the day, in like 2011, etc., before they changed, but it's become proportionally a much bigger component of the exam. It's about 20% of the exam now. Um, and yeah, with respect to geometry, I mean, you know, the generic advice is know all the rules at the starting point. Some of which are more intuitive and easier than others. Like in particular, things that you just like you need to master. You can't if you go into the
Yeah.
exam not knowing these things, you'll be in trouble. Right triangles, in particular, right triangles. Knowing 30, 60, 90, 45, 45, 90, the triplet 3, 4, 5, 5, 12, 13.
Hmm.
Um, just
Equilateral
having
triangles.
equilateral triangles, just understanding the Pythagorean theorem when it doesn't apply. Also, not over applying certain rules. Sometimes I'll see like if you're told a triangle has sides of 3 and 4, people immediately assume the next side is 5, but that assumes the right triangle. You might not be told that, so it's not as though every right triangle is going to be a right triangle. That might sound obvious, but on game day sometimes it's easy
Well,
to
they
miss
like
those
to
things.
they like to give you a right triangle looking diagram with that
Yep.
question too, right? So they will not trick you, but they'll make it harder on you.
Yeah, yeah, for sure. I mean, if it looks like a right triangle, sure, it's probably close to right triangle, but there's no saying it actually is a right triangle unless they specifically tell you that.
Right. And then
And
yeah,
then
you've got parallelograms, circles, cylinders, spheres, all that good stuff. Yeah.
yeah, yeah, there is a lot. I solids. I find people, especially like things like surface area. It's tested commonly enough that you should make sure you know those rules. But again, when try and memorize rules, understand them conceptually. I mean, that really is important. Like understand surface area. The sum of the areas of all the faces. What does that mean? And a lot of times you'll be able to derive the formulas instead of necessarily just blindly memorizing them. Also, coordinate geometry, super important. Like understanding just how lines in the XY plane work, understanding, properties of like what does it mean for lines to be perpendicular. Shifting graphs is interestingly something I find is pretty commonly tested. By shifting graphs, what I mean is, like if you have a parabola y equals x squared, and then all of a sudden it's y equals x squared plus 5, what happens when you do the plus 5? How does that change the outcome? Yeah, so rules in that vein are going to be important.
Graphs, I feel like, are like the part of geometry that a lot of people maybe don't think of,
Uh huh.
but is still in there, and they still
Yeah.
test it.
Yep. Yep. And yeah, we'll call it coordinate. I call it coordinate geometry, or that's why I lump it underneath geometry.
Yeah. All
Um.
right. So, I mean, we've so far it's really just nailing high school math. You got arithmetics, you
Yep.
got exponents, fractions, then you have geometry.
Yep. And
So,
then
what
this
is
will lead
next?
us to some potentially advanced high school math / college math, which is going to be statistics. So within
Hmm.
statistics, and by the way, ETS calls this data analysis. What we call statistics, really the same principle. Just dealing with sets of numbers, understanding properties that certain sets of numbers will have. So, the sort of core stuff with statistics, median, average, mode. Understanding how to solve for those, understanding the different manipulations available. Now, getting to some more advanced concepts within that, weighted average is very important, hugely tested topic. Understand it both intuitively and understand the formula. When I say intuitively, what I mean is like just understand. And I know that for the listener, this could sometimes be tough because I'm verbalizing this. You don't really see a whiteboard, but the idea, if one set has an average of 50, one set has an average of 30, whichever set has a greater number, the average will skew closer to that, right? So if we have a set of 50 with 10 people, a set of 30 with 10 people, the average is right in the middle. But if you have a set of 50 with 15 people, a set of 30 with 5 people, the average will be closer to 50. That
Hmm.
concept is tested very heavily, especially in quant comparison. And it is important the reason it's so important to understand that intuitively is on quant comparison in particular, you don't want to dive into that unnecessary math and make the question more challenging and time consuming than it needs to be.
Right.
So weighted averages, and then another component of averages, a kind of average question that gives people difficulty is dealing with evenly spaced sets. Evenly
Hmm.
spaced sets are situations where there's a constant spacing between successive numbers. So, like if you have consecutive evens 2, 4, 6, 8, or consecutive multiples of 5, 5, 10, 15, and so on, there's certain properties these sets have. You should be able to calculate the average of these sets, the median of these sets, the number of elements in these sets. And there are some formulas that, I'm sure your course covers that are really important to internalize.
Hmm.
And then the last couple components of data analysis, standard deviation, really important. Now, with respect to standard deviation, the good news is you do not need to know the formula.
Yeah.
That's a lot of people will start like, oh crap, there's this really weird like square root of the variance squared, blah blah blah. But no, that's not going to be relevant. You need to number one, you need to understand it intuitively, conceptually, because again, they will test it on quantitative comparison. And then what you need to also know is normal distribution. So 34, 14, 2, understanding that the data will be distributed symmetrically about the mean. 34% of the population falls between the mean and one standard deviation above the mean, and so on.
Right.
Definitely a tougher topic, but learning the distribution and understanding it, the intuitions behind distribution will be important for sure. There are some subtypes there, like there's like box and whisker plots, quartiles, things like that are those are pretty rarely tested. Let's just table those.
That's for when you've mastered everything else and you're trying to
Yeah,
aim for like a 170, right? And
yeah, yeah,
then you're
yeah.
worried about box and whisker plots.
Right, right, exactly. The last thing within data analysis is probability and combinatorics, which
Hmm.
are do merit some study time. Now, with a caveat that probability and combinatorics questions can be constructed to be very challenging. Be aware that you might in your studies encounter some just brutal probability combinatorics questions. In which case, it's not the end of the world to miss them. But understanding basic probability, understanding conditional probability, right? If I flip a coin 3 times, what's the chance I'll get heads all 3 times? That's very important. understanding, and then within combinatorics, like if nothing else, understand how to deal with permutations, how to deal with combinations, right? If I have 5 people, I'm gonna create that an arrangement of 3, how many different arrangements are possible. If I'm gonna choose a group of 3, how many groups can I choose? At least those foundational components of combinatorics you should master. And then, of course, there are gonna be some twists to them. They might ask you to combine subgroups, things like that. And the higher you, if you're scoring well, covering advanced combinatorics makes sense because again, right, if you're at 165, you want 170, you need to know some of the advanced topics. But at a minimum, just having a facility with the basic formulas is important.
Got it. And then anything else you want to bring up on what quant question types you should be practicing?
Yeah, and then the last one is just word problems, which is I say
Okay.
last one, which is not to say that it's not heavily
There's
tested. It
nothing else.
is.
Yeah. It's just the
Um,
last one that's really important. Yeah.
Yeah, exactly. So within word problems, we could categorize. I like to say algebraic translation, which is sort of your standard word problem of, like Jack has $10 more than Sam. Combined, Jack and Sam have $100. How much money does Jack have? Things like that. And then other subtypes, age questions can be very challenging. And then
Right.
rates as well, right? That's like the one topic that everybody finds difficult. One thing I will say with rates, in my experience, both seeing pretty much every published question that ETS has provided, also taking the exam. Work questions are a little bit more commonly tested than motion questions. So, situations where like Bob and Sam work together to do a job in 5 hours. Sam alone would take 8 hours. How long would it take Bob?
Right.
Versus motion questions, well, still are tested, but again, not as commonly. Motion questions being like, Jack is going 50 miles per hour for 30 hours. How far does he go? Things like that. Especially one subtype that in my experience has never been tested on the GRE is what's called relative rates. Relative
Mm-hmm.
rates are situations where, and motion questions in particular, where it's like Bob and Sam start at the same point and go in opposite directions. Bob goes 50 miles per hour, Sam goes 30 miles per hour, and how many hours will they be 800 miles apart? Things like that. They appear in most test prep curricula for the GRE, but I've never seen it tested. So unless you're, again, like really just shooting for the stars, want to cover every base, it's not really worth addressing that. But definitely mastering translations, mastering age questions, and mastering work questions, in particular, basic motion questions is very important.
Great. Thanks so much. This has been GRE Snacks, hosted by Tyler from Achievable with Erfun Gula from GMAT Compass. I promise you I'll get that right someday. Achievable has a great online GRE course you can try for free at achievable.me, and you can use the code podcast to get 10% off at checkout.